Today we're going to take a quick look at gold. It's more than just conductive metal that is pretty. Some things that I want you to keep a lookout for as we're learning about gold are what are its current and potential uses, what are its unique chemical properties that make it so interesting, and how is it extracted, and what are some of the concerns that we have with getting gold where we want it to in the first place. I'm going to start with a little bit of history. Gold is pretty. It's unique. It has a color that we don't find in nature, and it's also pretty rare. In fact, that's the reasoning behind its original uses as a status symbol. It was easy to work into shapes like necklaces and crowns, and its rarity made it easy to identify somebody of a higher status. Additionally, because of its rarity, it made good material to base trade on. And use as coins and currency as having a higher value than other metal coins. Fort Knox even houses a cache of gold to back our currency. Technically, the value of our dollar is equal to some specified amount of gold. And originally, we could trade in our dollar bills for the amount of gold that they are valued at. That kind of no longer happens. While our use of gold for jewelry doesn't really look like it's going anywhere, there is a little bit of a question of using it as a standard of trade, especially with banking methods favoring electronic currencies and credit. Speaking of electronics, that's another primary use of gold. We use it in the parts that do need to conduct electricity but are exposed. So if you checked out your phone, you would probably see that the charging jack, where you push your charger in, is probably coated in gold. Other important uses are in aerospace. We use it to coat parts that are going out into space. Astronauts have it impregnated into the visor of their suit. That same impregnation process we use in windows for skyscrapers. And because of its high electron density, it makes it really valuable in medicine. And actually, medicine we're going to look into a little bit more deeply because there are other uses there as well. What is it about gold that makes it so useful? First and foremost, gold has near noble properties. It doesn't react with a lot of things. Agents like oxygen do not easily react with it, making it ideal for coating materials to increase their longevity. In aerospace, this longevity is much looked for because they're going to be out in space where they don't want to have to do a lot of maintenance. Doing a spacewalk is not the best use of their time. So coating their materials in that reduces some of the maintenance that they may be required to do. Additionally, specifically in an astronaut's visor, it is actually being used for its reflective properties for solar rays. It is preventing the rays that could be detrimental to the astronaut, both in like sunburn on an unprecedented level, and reflecting the heat so that they can maintain the temperature inside of their suit. In fact, that maintenance of temperature is why we put it in glass in skyscrapers. We use it to reflect especially the infrared spectrum, preventing heat from transferring into the building. This means that we have to do less climate control on the inside of the building, which is a benefit. Gold, like all of the heavier metals, has a high electron density, and its relative inertness make it a good marker for medical imaging. In the center here, you see a CT image of the ribs. The upper left right here, you see a bright, dense spot. This is actually a tumor that has been marked with gold. They injected gold into the bloodstream, which had tags that were looking for the tumor and attached to it. so that when they took the image, they could actually get a better characterization of where this tumor actually is. Gold is also useful for the delivery of drugs, and it is one of the frontiers currently with the use of gold in medicine. It can form complexes, meaning that the gold is a central atom and it's connecting to other things that are actually going to be the particles that are used in medicine as a drug or as some other delivery mechanism. And because those items can break off and leave gold as something fairly inert, this makes it have an attractive quality that make it seem like it would be safe in use in biological processes. Gold, unlike other heavy metals that are more or less inert, can actually form complexes where the center is 2 gold atoms, meaning that you can almost double the concentration of whatever it is that you are trying to get into the body. So that's another useful application that they are very interested in looking into. One of the biggest concerns with gold is, how do we get it in the first place? Gold, as much as we would like it to, is not really found in nuggets. It is actually a fine powder that, due to its density, can actually settle through soil down to bedrock as water trickles through it. And that means that we have to dig it up. We actually have to dig deep down to find these places where it has collected. Classically, we know about the panning method, but it's too small to get the amount of gold that we need for any industry that is looking for it. So we actually primarily use heavy industry of strip mining, which you see an extreme version of here in this picture. If you've ever seen the show Gold Rush, you probably have an idea of what I'm talking about here. Unfortunately, not all countries have the money for this type of extraction. So they use something called mercury extraction, where they refine a sample down so that it's gold rich, and then they use mercury. They pour the mercury over the sample to pull the gold out of the sample, and then later they use this gold mercury ball and sort it out so that they can pull the gold out of it. Unfortunately, in both cases, we're talking about clear cutting. We're talking about an enormous amount of water that needs to be used for the separation, because they do primarily use density as its separation method. And you can see, especially from the clear cutting and the strip mining, it has a pretty big environmental impact. And additionally, in areas where they are allowed to use mercury, that has an impact on the health of the individuals who are actually trying to get it out of the ground. So that brings me to what we should be doing, and that's recycling it. But can we? The answer is yes, of course. Gold is infinitely recyclable. It could live in 50 different devices in a single year, and it would still be the exact same gold that we started with. There are a couple uses that do actually take it out of circulation forever, like using it in space probes. We're not going to follow those space probes out there and get them back so that we can retrieve the gold. But here at home, there is another source of gold waste, and that is actually cell phones and other electronics with short lifespans. Currently, our recycling methods just aren't that good, primarily because we don't collect it very well. So we can't break down our cell phones and extract the gold and other valuable minerals from them. So for the moment, we do actually consider these uses that use up gold and take it out of circulation indefinitely. There's a lot more to learn about gold. So I will post this in our digital classroom so you can peruse some of the sources that I have for you. Here is a page that has resources related to the actual chemistry of gold, how it reacts and stuff. Another page I have is some of the current research in medicinal uses for gold, because it's, quite frankly, my favorite. And finally, I have Some resources if you are interested in actually becoming a gold miner.